Arithmetic progressions over here. Let's look at it. Arithmetic progression, before we get into the formulae and all of that, right? So in fact, before arithmetic progression also, I was just saying that we can look at the differences between sequences and progressions, right? Theory, we've seen that in the lesson. Not very important. A sequence is something which has a pattern. Progression also has a pattern, yes, but on top of it, it also has a formula, or yeah, a set formula to find the nth term, right? To find the nth term. An example of a sequence is a prime where you can't find the nth term with a formula, so it's not a progression. But a progression over here, you have a formula to find the nth term. We'll see that for the different progressions over here. Arithmetic progression, AP, GP, geometric progression, harmonic progression, HP. Amongst the three, AP is the simplest one, and this is where most of the questions turn up in the CAT exam. 80% of the total progressions questions come from here. That is AP, GP, HP combined. If only those three you're looking at, 80% of it will be from AP itself, right? So what do we have with AP? First step is writing the terms over here: A plus D, A plus 2D, and so on till A plus N minus 1 into D, right? So we've seen this. Now, why is it N minus 1 into D? And what are these A and D and all of that? A is your first term. D over here is the common difference. And N over here is the number of terms. Number of terms. Now, A is the first term. A plus D is the second term. A plus 1D. Third term over here, I'm adding only 2Ds because A was my first. I'm adding 2Ds to it. Fourth is A plus 4D. 97th term is A plus 96D. And nth term is A plus, subtract a 1 from N, A plus N minus 1 into D. That is my nth term over here. Now, when it comes to finding the average, right? So the average of these is nothing but the first term plus last term over here divided by 2. Can also be a second plus the second last by 2, or third plus the third last by 2, right? So all of those, we are moving by 1 to the left and moving by 1 to the right. The total doesn't change, so that continues, right? But average, typically we use this quite often in the test. The first term plus last term by 2 is the average of all the terms in this AP, right? So that's the average, simple average formula. But if you want to plug in these A and A plus N minus 1 into D, we can write it as A plus A plus N minus 1 into D. So 2A plus N minus 1 into D divided by 2. Now the average is also the median over here. What is the median? The middle term, right? But if we have two middle terms, because there are even number of terms, 6 terms are there, third and fourth are the middle terms, then median is the third plus fourth divided by 2. Median, or the what we apply, right? Arithmetic of middle terms, arithmetic mean of middle terms, right? As that is the case when it comes to median of even number of terms. It continues. So an average in an AP is always equal to the median of the AP, right? The middle term or the average of the two middle terms. Continuing, average can also be written as 2A plus N minus 1 into D by 2. So the total or sum of N terms is going to be what? Average into number of terms. This average, 2A plus N minus 1 into D by 2 into N. I take the N by 2 out, and the rest of it I'm going to write it as 2A plus N minus 1 into D over here. This becomes the sum of N terms of an AP formula. N by 2 into 2A plus N minus 1 into D, where N is number of terms, A is the first term, and D is the common difference, right? So this bit we need to remember clearly. And the other thing to note over here is the median is the arithmetic mean of an AP. The median, the middle term, is the median is the AM of the AP. Arithmetic mean of the arithmetic progression. That's it. Just in case for you to know, the median in the case of a geometric progression is going to be the geometric mean of the GP, and in the case of an HP, the median or the middle term is going to be the harmonic mean of the HP, right? So that's how it's going to be. But right now, this is the more important part. The middle term is going to be the arithmetic mean of the AP. Now, a couple of other things we need to note. Very often, they're going to give us questions with three terms in an AP, right? Before we come to properties, we look at that. 3 terms in an AP, right? 3 terms in an AP. I would take the 3 terms as A minus D, A, and A plus D. right? So that the sum of these is going to be written as 3a. The d is disappears. They could tell me that sum of three terms in an AP is something. But when they tell me that sum of three terms of an AP is 30, I know that the middle term is going to be 10. That's the average. The middle term is the average of the AP, right? So those are the things we can find out quickly. And this part especially is used a lot in DILR solving as well. They could tell you that, the sales of three cities, Chennai, Hyderabad, and Delhi, are in AP in that order, or if that order is not mentioned, it is given to be, I mean, it's understood that it's in that order. Sales of Chennai, Hyderabad, and Delhi are in AP, and the total sales over here is 48 crores or something. Then I know the average of this 16 crores pertains to Hyderabad, right? The middle term. If it's an increasing AP, then this would be 16 plus X. This is 16 minus X. That common difference over here. This is the way we can close this out. So that's with small number of terms. Let us say AP with small number of terms, you could have 5 terms. I would take the 5 terms as A minus 2D, A minus D, A plus D, and A plus 2D. I'm not really writing it in the A plus N minus 1 into D form, but I note that the differences over here are all D, right? D is a common difference, but my first term is A minus 2D. I'm starting from there, right? It could also be handy where they might give me the product of the first and last, or the product of the second and third. I mean, second and fourth, right? I get A square minus D square. I get A square minus 4D square, right? I still work with two variables in these scenarios. Okay, so that's about it when it comes to small number of terms. If I have 4 terms given in AP, then we've seen this in the lesson. I would use A minus 3D, A minus D, A plus D, and A plus 3D, right? I'm using a plus D minus D and plus 3D minus 3D. The differences are, common difference is 2D, and this is my first term, right? Everywhere, if you note, the common difference is 2D, right? When it's even number of terms, I do it this way. If it's an odd number of terms, the middle term is A, to the left is A minus D and A minus 2D, right? And I go this way. So now on to the properties of arithmetic progression, right? So very quickly, so if you have A plus D, A plus 2D, and so on till A plus N minus 1 into D, right? So what happens if I'm going to add or subtract K, right? From each of the terms when it comes to AP over here, then my in an AP, let's say, um, my first term over here is going to become A plus K or A minus K. But my common difference over here remains the same. No changes to that. If I'm going to be multiplying or dividing by K, then my A gets, let's say multiplying, A becomes AK, D also becomes DK. Just look at it. If you multiply this with K, each of these, you get AK plus DK, AK plus 2DK, right? So my common difference becomes DK. AK is my first term. That's it. The AP still continues to be in AP, right? The terms are still in AP. There's no changes to that. This is the impact. Now, if I'm going to raise everything to the power of K, then it's not going to be in AP anymore. We stop at that. For arithmetic progression, if I'm adding or subtracting a constant or multiplying, dividing each of these terms with a constant, the AP continues to be in AP, although they have different values. Next up, the last concept over here before we move to some examples is inserting arithmetic means. If I'm told that I have 3 and 10 as the first and last, and I have to insert 7 arithmetic means over here, 7 arithmetic means, it simply means 3, and then I have 7 terms over here, and then 10. That's a total of 9 terms, 9 terms over here. These 9 terms are going to be in AP, which means A is my first term, right? And then they could ask me what's the common difference, right? If A is my first term, and what's 10 over here? My ninth term. Ninth term then becomes A plus 8D. A plus 8D becomes 10. A is nothing but 3. Take it there. 8D is 7. D is 7 by 8. The common difference here becomes 7 by 8, right? 7 terms over here between 3 and 10. Don't say 4, 5, 6, 7, 8, 9. That's only 6 of them. You need to insert 7 of them. Has this concept turned up a lot in CAT? No. Arithmetic means they're typically not been using. Some other exams it might. From a CAT perspective, I'm not very sure if it's going to exactly turn up. And if it does, now we know how to work with it. Arithmetic means if 7 have to be inserted, including the first and the last, that's a total of 7 plus 2, 9 terms. They're all supposed to be in AP. That's all it means. Right, so let's start with an easy one, question one over here. If the square of the seventh term of an AP, right, seventh term would we see? A plus 60 whole square, right? Seventh term is going to be A plus 60, A plus n minus 1 into D. With positive common difference, find D is positive, equals the product of the third and the 17th terms. Third is A plus 2D, and 17th is A plus 16D. I shouldn't make a mistake with that. Just expand this. A square plus 36D square plus 2 into 6 is 12AD equals A square plus 2D into 16D is going to give us 32D square plus 2AD plus 16AD is 18AD, and A square is cancelled. 4D square we get here. If we move this 12AD there and we get 6AD, D is cancelled. Ratio of first term to common difference A by D, then 4 by 6, which is 2 by 3, 2 is to 3. Option 1 becomes the answer. Let A1, A2 and so on till A3n be an arithmetic progression with A1 equals 3, that's the first term, A2 equals 7, common difference I know. So A equals 3, common difference 7 minus 3 is coming to 4. I don't know the number of terms, right? For now, this 3n and all is too much for me. Let me just use n. Later, I will divide it by 3, right? I'm used to using n. So let me just take it as n. So n equals 3n or something like that. We'll just take it as, and I'll bring it back. Yeah. So right now I'm going to use n. Now sum of these is going to give me 1830. The formula I know, n by 2 into 2a plus n minus 1 into d. So n by 2 into 2 into 3, 6 plus n minus 1 into d over here, which is 4, equals 1830. Okay. So n, and what do I get here? 4n minus 4 plus 6. So 4n minus 2 equals 2. I take it there. 1830. I want to write it as product of two terms. It's n into 4n minus 2. Let me factorize this. 2 into 10 into 183. 183 is going to be a 3 into 61. And 61 is prime, right? So I stop it at that. Yeah, so back to this. I think this is 4n plus 2, right? So because of 4n, yeah, correct, minus 4 plus 6, it comes to 4n plus 2, right? So n into 4n plus 2 should give us this. Now, this is going to give me a 60 into 61. Now, 60 into 61 over here is too close. I want it to be quite apart. Trial and error, it can end with a 2. I need a 10 multiple. 2 you multiply over here. You get a 122 and you get a 30. If n is 30, 30 into 4, 120 plus 2 is 122. It all works out correctly, right? If n is 30, this becomes 122. That's it. N has to be an integer. Factorize it and try to find out. Do not use quadratic equations over here to solve for this. So once you found n to be 30, this is 30, 3n is 30, then n is going to be 10 only. I want to know the sum of the first 10 terms. First 10 terms is going to be 10 by 2 into 6 plus n minus 1, 9 into 4, right? 9 fours are 36, 36 plus 6 is 42, 420 by 2, which comes to 210. That's the sum of the first 10 terms over here, 210. This 210 into m into 210 should be greater than 1830. So 21 into what is 21 into 8 is going to come to 168. No, 21 into 9 over here is coming to 189. It works out. So option 2 becomes the answer. Or you can divide it in the calculator and find it to be some 8 point something. The smallest integer, positive integer, is going to be the next one, which is 9. So question 3 over here, right? So again from CAT 2017, some were easy, some were tough, right? So let's look at this. Let A1, A2, A3, A4, A5 be a sequence of 5 consecutive odd numbers. 5 consecutive odd numbers. A1, A2, A3, A4 and A5 consecutive odd numbers. Fine. Common difference is 2 and they're all odd. Consider a new sequence of 5 consecutive even numbers ending with 2a3. So 1, 2, 3, 4, 5. This time it is 2 times a3, which is my last number over here. And they're all going to be consecutive even over here. And these are consecutive odd over here. Okay. If the sum of the numbers of the new sequence, the second one is going to be, sum is going to be 450. Then the average is going to be the middle term. 450 by 5 is going to be my middle term, 90. And I want to get to 2a3. So I keep adding to 92, 94, consecutive even. If 94 is 2a3, a3 is going to be half of this, which is 47. I need to find a5. Keep adding to 49, 51, and that becomes the answer here. So question 4, the number of common terms in the two sequences 15, 19, 23, 27, and so on till 415, and 14, 19, 24, and so on till 464 is what? It's a standard type where we need to first identify the first common term, and that's given to me over here in the series itself. The first common term over here is going to be 19, right? And what is going to be the last common term? Now, how do I find that? So the next common term at least I have to find. Here the common difference is going to be D1, I'll call it. That common difference over here is 4. Here D2 is 5. Now every subsequent term is, I can add a multiple of 4. Every time I add a multiple of 4, I'm going to find a term in this AP. Here when I add multiples of 5 to 19, I'm going to find a term in the AP, 19 plus 5 or 19 plus 2 into 5, 9 plus 3 into 5 and so on. What is the LCM of 4 and 5? So 4 and 5 LCM is 20. When I add 20 to this, 19 plus 5 into 4, I'm going to find 39 over here. When I add 19 plus 5 into 4 into 5, 4 terms after this, 5, 5, 5, 5, 4 times if I add it, I am going to find a 39 over here as well in the second sequence. So what I can say is now my common difference has become 20, right? Common difference over here, the combined common difference starting with 19, A3, right? The common sequence I'm looking at. A3 is 19. The common difference should be a multiple of 4 and 5, the common differences of the two individual APs. So 20 over here. Every 20, if I add, I'm going to find it in both the APs, right? Because the multiple of 4 and 5. Now, how many terms are going to be common, right? How many terms are going to be common? 415 or 464, which is smaller, 415 is smaller, right? 19 plus n minus 1 into 20. A plus n minus 1 to d is my nth term. That nth term should be less than 415, right? Less than or equal to 415. Let's see what we're getting. 20 into n minus 1 is less than equal to, take the 19 there, it's going to be 396. 396 divided by 20, divide by 2 first, and we're going to be getting 192. N minus 1 over here is less than equal to 19.2. N is less than equal to 20.2. What is the largest integer less than 20.2? That's going to be 20, right? 20 over here. That's the largest integer less than it. Once, if we want to check, let's check my nth term over here. My nth term is going to be 19 plus n minus 1. If I'm saying 20, 20 minus 1 is 19 into d over here, right? N minus 1 into d. This is coming to 380 plus 19, 399. 399 is over here. And if I add another 20 to it, it becomes 419, which is not present in the series. Up to 399 I can go. And therefore, option 3 becomes the answer over here. Then we should move to geometric progression now, right? The formulae, average, and properties. When it comes to geometric progression, it's going to be a little simple, right? So in terms of the extent to which you could be asked, the questions aren't going to be too complex. They're going to be sticking to the basics. Now, what's the primary difference between geometric progression and AP? AP, we kept adding a common difference. Here, I'm going to keep multiplying something, and that we call the common ratio. So R is used. AR, AR square, and so on. My nth term is going to be AR power n minus 1, right? N minus 1. First term is A, second is AR power 1, third is AR square, right? 3 is 2 over here as a power, nth term is n minus 1 as a power, and that's it. Now, without getting into too much detail, right? So a few important things alone we look at over here. Sum to n terms over here is going to be a into r power n minus 1 divided by r minus 1. Sum of the first n terms of a GP. How to derive that from a simple algebraic expansion identity, right? So I mean, that's given in the lesson again, but at this moment, knowing this is sufficient. Now, sum to infinity, sum of infinite terms in the GP is equal to a by 1 minus r when 0 less than r less than 1, right? Your r is going to be between 0 and 1. Then it's reducing, right? You're multiplying with a number which is less than 1, it keeps reducing. So sum to infinity can be found, and that's going to be a by 1 minus r. A couple of other things you have to note with geometric progression is your common ratio can be a negative term, right? For instance, a can be 2, let us say, and let's start with this. If a is 2 and r is 3, then your terms are going to be 2, 2 into 3, 6, 6 into 3, 18, and so on. This is an increasing GP. Now, if a is going to be 2, r is going to be 1 by 3, then we're getting 2, then 2 by 3, 2 by 9, right? 2 by 3 into 1 by 3. This is a decreasing GP. Now, what if your a is going to be 2 and your r is going to be minus 3? Then your terms are going to be first is 2, next is minus 6, next is plus 18, next is minus 54. There's no pattern. It's neither increasing nor decreasing. Neither increasing nor decreasing GP. And this happens when your R becomes negative. So GP, as I said earlier, you're going to have A, AR, and so on till AR power n minus 1. What's going to be the average? First term plus last term by 2? Nothing like that. But what I can tell you is the geometric mean is the geometric mean of the first and last terms. There it was arithmetic mean, so arithmetic mean of first and last. Here the geometric mean is geometric mean of the first and last terms, a into AR power n minus 1. The median is going to be my geometric mean over here, right? The median, the middle term is going to be, right? So let's look at an example now. Let's work with question 5, right, from a CAT 2018 paper. Let x, y, z be 3 positive real numbers in geometric progression such that x is less than y is less than z. Okay, GP. So I can take a, AR, and AR square. X is less than y is less than z. Right. So therefore, R is going to be greater than 1. R is going to be greater than 1. It is increasing GP. Okay. If 5x, 16y, and 12z are in AP, arithmetic progression, then the common ratio is going to be what? Right? In arithmetic progression, if 3 terms are in AP, then the common differences are going to be equal. So 16y minus 5x is going to be equal to 12z minus 16y, right? That's one way to write it. Or those of you know it, 2 times the middle term, right? 2 times the middle term, 32y equals sum of the other 2 terms, 5x plus 12z, right? Sum of the other 2 terms, sum of the first and last terms equal to 2 times the middle term when you have 3 terms in an AP. But essentially, both of these are the same. Bring the 16y here, becomes 32y, take the 5x there, becomes 5x plus 12z. So back to this, where x, y, and z are defined as a, AR, AR square. So if I'm going to plug a y as AR, I'm going to get 32 AR equals 5a plus 12 into AR square, right? 12 into AR square. I can cancel an A everywhere. And what do I need to find? I need to find the common ratio, right? I need to find R. So 12R square minus 32R minus 5 equals 0. And 12 into minus 5 minus 60, or hold on. So it's actually a plus R, a plus 5, right? Plus 5 over here. 12 into plus 5 is plus 60. Minus 32 can be split as minus 30 and plus 2. So what do we do? Direct one step thing, which we'll be seeing under quadratic, right? Revision. Minus 30 and minus 2, I can split it as, switch the signs, divide by the coefficient of r square, and that's it. We found the two r values. What are they? 30 by 12, which is 5 by 2, or 1 by 6. But r has to be greater than 1 because of this inequality. So r greater than 1 is only 5 by 2. So option 2 over here becomes the answer. Okay, so this is another common type of question which turns up, right? So which turns up pertaining to GP. It's disguised in a different way, right? So let's understand this. A tennis ball is initially dropped from a height of 180 meters. Okay, from 180 meters it is dropped. It hits the ground over here. Okay, it hits the ground, so it has covered 180 meters. After striking the ground, it rebounds 3/5 of the height from which it has fallen. 3/5 of 180 meters over here, 1/5 is 36, 36 into 3 is 108. So it goes up 108 and then it has to come down 108. 108 and 108. 3/5 it's become. Then, what does it say? After striking the ground, it rebounds 3/5 of the height which it has fallen. The total distance the ball travels before it comes to rest. Which means if it comes down, again it's going to go 3/5 of the height and comes back over here. Right? 3/5 of 108, and this is also 3/5 of 108. Right? This continues. That's it. There's a set pattern and it keeps reducing, and finally it's going to come to rest. Sum of all of these, 3/5 over here is used every time as a multiple. That's the common ratio. Sum to infinity it looks like, and it is, right? So what is this sum we need to find? We need to find 180 plus 108 plus 108 is 216 plus 216. 108, what is this? 3/5 of 108 plus 3/5 of 108. That is 3/5 of 108 plus 108, which is 216, plus this should have been 3/5 of this total. So I already have 3/5 of 216. So it's 3 by 5 the whole square into 216, and it continues till infinity. So what am I getting over here? The 180, I'll keep it as it is. This looks like A. This is AR. This is AR square, or rather R square into A, right? This is R into A. R is 3 by 5. The formula for sum to infinity over here, when my R is between 0 and 1, it's 3 by 5, 0.6. It's nothing but A by 1 minus R. So A, 216 divided by 1 minus 3 by 5. 1 minus 3 by 5 is 2 by 5, right? So this 2 by 5. 2 by 5 is nothing but 5 by 2, reciprocal over here. Here I get a 108. 108 into 5 is going to be a 540. So 180 plus a 540 comes to 720. Option 3 becomes the answer here. So the next concept is that of harmonic progression, right? So what's a harmonic progression? It's simply a reciprocal of terms in AP, meaning if 2, 5, 8, 11, etc. are in AP, correct? Then 1 by 2, 1 by 5, 1 by 8, 1 by 11 are in HP, harmonic progression. That's it. So how do I define HP? 1 by A, 1 by A plus D, 1 by A plus 2D, and so on till 1 by A plus N minus 1 into D. The median term over here is going to be my harmonic mean of the HP. The entire thing, if I take the harmonic mean, that's my median term, right? So that's about it from a concept perspective. Nothing major I need from here. If at all you need to work with and solve something, you know that you can take the reciprocal for each of them, and you'll know that the common differences are going to be the same, because the moment you take a reciprocal, it gets converted to an AP. The terms in HP, you take the reciprocal, it gets converted to AP, and use that to solve it, right? So don't have an example over here. Not going to be getting into this part, right? Now let's move into the special types. So the first concept here, squares, cubes, and all of that, and difference of difference, and difference of difference, right? So these I've given you. I mean, this is actually used for arithmetic or geometric sequence, which we'll look at shortly. But we also need to establish a pattern over here, right? So 1 square, 2 square, sorry, 2 square, 3 square, and all of that. What are they, right? So 1, 4, 9, 16, 25. If we take the differences over here, what are we getting? 3, 5, 7, 9. But if you take the difference of the difference, that's going to be a 2, 2, 2, and it's the same everywhere. So the differences of squares are going to be in AP. The difference of differences are going to be a constant, right? So some of these you can just list it out and check for the difference or difference of difference and work it out. You will realize that a constant emerges, right? Where do we apply? We look at a simple example over here, right? So something which turned up in IFT 2008. 1 square minus 2 square plus 3 square minus 4 square and so on. And we are going up to 2003 square, right? Which value is it going to be? Now, from this itself, we need to understand, or by the look of it itself, we notice that two terms consecutive from the rightmost end, they look like we're just finding the difference of two adjacent squares. 2003 square minus 2002 square. And this would have been 2001 square minus 2000 square, and so on. All right. And if we keep removing two at a time, if we keep looking at two at a time, and here we come to 3 square minus 2 square, and then I'm left with a 1 square over here. Can also be a 1 square minus 0 square, right? 1 square minus 0 square. But what is the pattern over here? What is the standalone 1 square? That's a 1. What is 3 square minus 2 square? A square minus b square is a plus b into a minus b, right? A plus b into a minus b. If I'm taking adjacent squares and I'm subtracting, what happens over here is this 3 minus 2 over here is becoming 1. This is nothing but 3 plus 2. 3 plus 2 into 3 minus 2, that becomes a 1. So 3 square minus 2 square is nothing but 2 plus 3, right? Next, 5 square minus 4 square is just going to be 5 minus 4, which is 1, into 5 plus 4. I can write it as 4 plus 5. Next up, I can write it as 6 plus 7. And this continues. And what do we get towards the end? 2003 square minus 2002 square is simply a 2002 plus a 2003. Now, what this is translating into is simply the sum of all the terms from some of the first n natural numbers or first 2003 natural numbers, right? The formula over here, we'll be looking at that later, but we should note at this stage, some of the first n natural numbers is n into n plus 1 by 2. And I think this is something which all of you would be knowing. 2003 into 2003 plus 1, which is 2004 divided by 2. Divide over here, you get a 1002, 2003, 1002. In the exam, calculator is not working, right? You can just do 4006, 1 over here, right? So you shift by 0, and 1 to this is going to be give you 2003. You add it up, 2007, 006, and that for you, option 1 is the answer over here. Next is an arithmetic or geometric sequence, right? We'll just take it up with an example over here. The infinite sum of 1 plus 4 by 7 plus 9 by 7 square plus 16 by 7 cube and goes on till 25 by 7 power 4, right? So numerator over here, it's like squares over here. Denominators are in GP types, right? So what do? For squares, difference of difference is a constant. So probably 2 times I would take the difference. So what shall I do over here? I'll write let S be equal to, we can write 1 plus 4 by 7 plus 9 by 7 square plus 16 by 7 cube plus 25 by 7 power 4 plus 36 by 7 power 5. I'll just write one more, right? And then a dot, dot, dot. Now, all I need to do is multiply with 7. When I multiply with each of these terms with 7, I'm getting a 7 plus, right, 4 by 7 into 7, that gives me a 4, plus 9 by 7 square into 7 is 9 by 7, right? I'm moving everything by one space and writing it. 16 by 7 cube into 7 is 16 by 7 square, right? 1 7 gets cancelled. Entire thing, if I multiply with 7, everything gets moved by one place with respect to the denominator, right? And once I do that, what do I need to do? I just need to take the difference bottom minus top. 6s over here is 11 minus 1, which comes to 10, plus 9 by 7 minus 4 by 7, which is 5 by 7. 16 by 7 square minus that is going to give me 7 by 7 square. Here I'm going to get a 9 by 7 cube. Next I'm going to get 11 by 7 power 4. Now it's an AP. One more difference is going to help us out over here. Into 7 again is going to give me 42s, right? 7 into 6s, which means I'm going to get a 70 plus 5 by 7 into 7 is a 5. 7 by 7 plus 9 by 7 square plus 11 by 7 cube and so on. If I take the difference over here, it's going to be 36s equals 75 minus 10 is a 65 plus here it's a 2 by 7 plus 2 by 7 cube, 7 square plus 2 by 7 cube and so on to infinity, right? So 36s equals 65 plus first term 2 by 7 divided by 1 minus r. R over here, every subsequent term I'm multiplying with 1 by 7, right? 1 minus 1 by 7 is 6 by 7, right? So there's nothing but 65 plus 2 by 7 by 6 by 7, 7, 7 cancel, 2 by 6 is 1 by 3. 65 plus 1 by 3, if I take the LCM, it's going to be 65 into 3, which is coming to 195 plus 1, right? Which is going to be 196 by 3, right? So 196 by 3, I can bring the 36 down. We're going to get S equals 196 divided by 36 into 3, which comes to 108 over here, right? What does it look like? 196 and 108, I can divide by 4, and we're going to get a 49 by 27, right? So option 3 over here becomes the answer. Next up is terms getting cancelled. How do they get cancelled? Let's try this out. Consider a sequence where the nth term Tn equals n by n plus 2, where n is 1, 2, 3, and so on. The product of T3, T4, and so on till T53. What is T3 over here? 3 is 3 by 3 plus 2, 3 by 5. Into 4 is going to be 4 by 2 more 6. Next, 5 by 2 more 7. 6 by 2 more, which is 8 over here, and goes on to T53. 53 divided by 2 plus 53, 55. 1 before that, 52. 1 before that, 51. Let's just write them down. 50, this is going to be reduced by 1 and reduced by 1. Right? So what are we seeing over here? It's all going to be multiplied. 5, 5, right? 2 later, 2 later, 2 later, 2 later. It's going to get cancelled. And what are we going to be left with? I'm going to be left with the first 2 terms. I'm going to be left with the last 2 terms, right? 53 would get cancelled here. 52 before this would have been cancelled over there. So I'm left with the first 2, 3 into 4, 12 divided by, or we can just keep it as 3 into 4. Terms can get cancelled over here. 54 into 55. 3 is going to give me an 18, and 4 over here is going to give me a 9. 9 into 50 is 450 plus a 45, 495, and numerator is 2. Right? Option 1 becomes the answer here. So on to question 10 over here. Right? Terms getting cancelled looks like a slightly difficult question, right? We need to understand, take our time over here. A recent CAT question. On day 1, there are 100 particles in a laboratory experiment. Fine. Day 1, we have 100 particles. Now on day n, where n is greater than or equal to 2, 1 out of every n particles produce another particle. So 1 out of every n. So if there are two particles, then 1 extra 3 is created, right? On day 5, what is going to happen? For instance, on day 5, 1 out of every 5 is creating another one. So extra 1/5 is being produced. On day 6, if there are 6 particles, 1 extra is produced. So for every 6, 1 extra is produced. So 1/6 extra is being produced. So essentially what it means is every subsequent day, every subsequent day where day n is there, extra 1 by n particle is being produced. Extra 1 by n. So extra 1 by n simply means multiplication factor. So on day one, right? Conceptually, it looks difficult, but yes, it is. But after that, it becomes easy, right? Once again, what does it mean? If n equals 2, for every 2 particles, 1 extra is produced. So if I have total of 100, for every 2, right? For every 2, 1 extra. So 50 extra is being produced. So 50 extra means it is increasing by half, increasing by half first, right? Whatever the number comes, the next day, for every 3, 1 extra is produced. So it's increasing by 1/3. The next day, for every 4 extra, 1 is produced, increasing by 1/4. Once we understand that, 100 into multiplication factor. 1 plus 1 by 2 is 3 by 2. Next day continues to be multiplied. Multiplication, successive growth, right? Change. 1 plus 1 by 3 is 4 by 3. 1 plus 1 by 4 is 5 by 4. And so on. It goes on till that last day. And what's going to happen over there? It has to come to 1000, right? I need to know that day M, what is it going to be? Day 2 over here, day 3 over here, day 4 over here. The denominator is 2. Denominator is 3. Denominator is 4. That tells me, right? What's going to happen now? 3, 3 are cancelled, 4, 4 are cancelled, 5, 5 are cancelled. My first term's denominator and the last term's numerator should be there because all of these should get cancelled. So 100 into something by 2 should give me 1000. 100 into what is 1000? 100 into 10 is 1000. Something by 2 should be 10. 20 by 2 is 10. So this should have been 20 by, what's in the denominator? 1 less, 19. This is going to be day 19 over here. 19 over here. Option 1 becomes the answer. They could have made this difficult with having 20 in the options, which they didn't, right? So this was from the slot which I had written. Next on to splitting terms, right? Splitting terms. Let's take it up with an example itself, right? Something which turned up a while back, CAT 2017. So yeah, so what are these questions about, right? So these questions are about splitting this into 2 terms and subtracting. So 1 by 2 into 5 can be written as 1 by 2 minus 1 by 5, right? But if I take the LCM over here, I'm going to get 5 minus 2 divided by 2 into 5. Denominator becomes 2 into 5. But that 5 minus 2 is giving me a 3, and I don't want it 3. So I'm going to make it a 1 by 3 over here. Standard type we've seen in the lessons, right? This should be your immediate next step. Next is going to be a 1/3 into, it's going to continue, just look at it. 1 by 5 minus 1 by 8, right? So yeah, we take the LCM, it's 8 minus 5 divided by 5 into 8. 3 gets cancelled. And we are back to this. This process is going to continue over here. But what they haven't told us over here is what is going to be the A100 over here. A100 over here, 1 by 3 into what minus what, right? So A1, we used, A1 had a 2 there, starting with a 2. A2 was starting with a 5. A3 was starting with an 8, right? And that's the pattern. What's A100 going to be? The first term is A100 over here is going to be A plus n minus 1. N minus 1 is 100 minus 1, 99 into the common difference. And what is A? 2 plus 99 into common difference over here is 3. So 99 into 3. And that's giving me 297 plus 2, 299. But what was I looking at? 2 over here was my first term. In A2, 5 was my first term. A3, 8 was my first term. In A100, 299 will be in the first term's denominator. So 299 minus 1 by 299 plus 3, which is 302. So if I'm going to take a 1 by 3 common over here, I don't even need to do this. At this stage itself, you could have cancelled out 1 by 5 and all of that. Plus 1 by 5 minus 1 by 8 plus 1 by 8 minus 1 by 11, and this would have continued, plus 1 by 299 minus 1 by 302. So all of these are going to get cancelled, right? Till this, we're going to be left with the first term and the last term. So it's going to be 1/3 of half minus 1 by 302. Take the LCM, you get a 302. 151 minus 1, well, that's a 150. Divide, you get a 50. Divide by a 2, you're going to get a 25 divided by 151. Option 1 becomes the answer here. Right. So the next concept, or rather, next bit of formula you need to remember, are those pertaining to the sum of the first n natural numbers. That's n into n plus 1 by 2, right? Sum of the first n natural numbers. Sum of the squares of the first n natural numbers, n into n plus 1 into 2n plus 1 by 6. And that of the cubes is going to be n into n plus 1 by 2, the whole square, right? What is this? 1 cube plus 2 cube, so on till n cube is going to be this. 1 square plus 2 square and so on till n square is going to be this. 1 plus 2 plus and so on till n is going to be this. But summation can also be written as sigma I equals 1 to n xi, right? Xi, that's it. Or n, right? N is what we use. 1 to n, 1 to 10, right? We can have n equals 1 to 10 and we have sigma n or something like that. First 10 natural numbers. Here we write it as n equals 1 to 10 or something. N square we can call it, right? 1 square plus 2 square and so on. And likewise over here, n cube, n equals 1 to 10 means the first 10 cubes we have to add up, right? These we'll have to use in certain questions, right? So one such example is something like this, right? Eventually we need to find the sum of the first n natural numbers, right? So let's take a look at this one. Let's see how to do this. Sum of 2n plus 1, 2n plus 3, 2n plus 5 and so on till 2n plus 47 is 5280. How many 2n's are there? Starts with 1 and then 3 and then 5 and so on. 1, 3, 5 and so on till 47 is in AP, right? So the number of terms, I'll call it capital N, is nothing but last term minus first term divided by 2 plus 1. That's counting number of terms in AP. Last term minus the first term divided by common difference of 2 plus a 1, right? Is the number of terms. That's going to give me 46 by 2, which is 23 plus 1, 24 terms. Now, a few other things, if you remember, you would be pretty quick. The sum of the first n consecutive odd natural numbers is going to be n square. 1. Sum of the first two odd numbers is going to be 4. Sum of the first three odd numbers is going to be 3 square, 9. Sum of the first 4 is going to be 4 square, which is 16, and so on. If you know this pattern is there, you will know that the sum of the first 24 odd natural numbers is going to be 24 square, right? So 24 square we have here, and 24 times if you add 2n, you're going to get a 48n plus 24 square equals 5280, right? So 5280. So now I can cancel a 48 on all sides, right? If I take a 48 out, I'm going to get an n plus 24 is out. Along with that, another 2 from a 24, left with 12. 5280 is 48 into what? Divided by 48. 148 is 48. And then 448 is another 1 and then a 0. Cancel it out. N equals 110 minus 12, which comes to 98. I need to add up all the natural numbers 1 to 98. It's n into n plus 1 by 2, right? 49. 49 into 99 is 49 into 100 minus a 49 into 1. It should be 4851, and that becomes the answer for this question. There is more use for this formula around sigma, right? Sigma separating the terms, summation, right? Let's take it up with an example over here, right? So 2018 slot 2, one of the tougher years, 7 into 11 plus 11 into 15 plus 15 into 19 and so on till 95 into 99. First is for me to find out how many terms are there, but what is the pattern here? The common difference here is 4. Every first term, if I look at, it's increasing by 4 everywhere, right? It's increasing by 4 everywhere. How many terms are there? 95 minus 7. 95 minus 7 divided by common difference, which is 4 plus a 1. That's the first thing. 95 minus 7 is 88. 88 by 4 is 22 plus 1. 23 terms are there, right? Total of 23 terms. Now, this is the next step, right? Got to be careful with these. The next step is going to be, if I'm going to be calling this term 1, right? What number format is it? I want a 7. I want a common difference of 4 over here. So I have to call it a 4 into 1. 4 into 1 and 7. How do I get 7 over here? 4 into 1 plus a 3, right? We need to remember this. 4n plus 3 is giving me 7. What about T2? 4 into 2, 8 plus 3 is giving me 11. 4 into 3, 12 plus 3 is giving me 15. This number pattern continues. Why did I start with a 4 over here? Because 4 is my common difference. Common difference into number of terms plus my first term or whatever. If 4n plus 3 is 7, the next term is just 4 more than the previous. 4 more than the previous. 4 more than the previous is just 4n plus 7. So just try out once if you want. Try out for T23. I know that's my 23rd term. 4 into 23 is 92. 92 plus 3 is 95. 92 plus 7 is 99. Everything is perfect. Right? Perfectly fits over here. Sigma n equals 1 to 23. Right? 23. First 23. I have to plug in 23 over here. All I need to do now is to expand this. Expand this. So I need some space over here. So first step is to expand it. We're going to get 16n square, right? Sigma, the entire thing, 16n square plus 12 plus 28. That's a plus of 40n plus 7 threes are 21, right? N equals 1 to 23. Note the key things over here. As its summation, I can apply sigma to each of these. When I applied sigma to 16n square, the coefficient can come outside the sigma. I can write it as sigma of 16 into sigma of n square plus 40 into sigma of n. It's all 1 to 23. We'll come to that. Plus 21 constant. What does it mean? 23 times I have to add 21, right? 21 for n equals 2. Once again, I'm getting a plus 21. N equals 3. Once again, a plus 21. So sigma n equals 1 to 23 of a constant is that constant into number of terms, 23. That's it, right? So where it's n square, n into n plus 1 into 2n plus 1 by 6. That's the formula we saw. I have to plug in a value of 23, right? 23, n equals 1 to 23. So what is it going to be? 16 into n plus 1 into 2n, 46 plus 1, 47 by 6 plus 40 into n into n plus 1 by 2, 23 into 24 by 2 plus 21 into 23, right? We either use the calculator, but also to be noted, my last digits are all different over here. We could use that to close it out as well. But let's see how. So I can take a 23 common, right? Or before that, let's just simplify this a little. I'm getting a 4 and a 2 over here is going to get me to a 20, right? 20. And if I take a 23 common everywhere, I'm left with a 16 into 4 into 47. 16 into 4 into 47 plus 23 is out. So 20 into 24 plus a 21 over here. If I want to focus only on the last digit to close it out, only the last digit, 3 into, right, only the last digit over here, 3 into 6 fours are 24, 4 into 7 is 28, 8 plus 0 over here, plus 1, 8 plus 1 is 9, 9 threes are 27. Earlier days, without the calculator, this is how we'll solve it and keep going. 80707 has to be the answer. But nowadays, you can always open the calculator, substitute over here. I mean, just multiply these and see as to what we're getting. And we should be getting 80707. Okay, so let's look at question 14 over here. This was the question where, as I said, it took a lot of time, right? This was the second question for me. I think it's best to go in for questions like these if there are no other easy questions to do, right? Consider the AP 3, 7, 11 and so on, and let AN denote the sum of the first n terms of this progression. So AN over here, if it's the first n terms, it's n by 2 into 2a plus n minus 1 into the common difference over here. What do I know? I know my first term is 3, always. The common difference over here is 4. I just need to plug it in over here, and I get n by 2 into 2a, which is 6, plus dn, right? 4. 4n minus 4. 4n minus 4. I can cancel a 2 over here, and I'm going to get n into 2n, and then there was a plus 2, which becomes a plus 1. So n into 2n plus 1. So what I need to effectively find over here is 1 by 25 into sigma n equals 1 to 25, n into 2n plus 1, which is nothing but 2n square plus n. Okay, I can individually take these. I'll keep the 1 by 25, and I will write it as 2 times sigma n square, right? 1 to 25, I should remember, plus sigma n, right? That's the idea. Now it's n is 1 to 25. I can directly now plug in the formula 1 by 25 into 2 into n into n plus 1 into 2n plus 1 by 6. So 25 is n means 25 into 25 plus 1 into 2n plus 1, that's 51 by 6 plus sigma n into n plus 1 by 2, 25 into 26 by 2 over here. 2 I can cancel with this and I get a 13. I cancel a 2 over here and I get a 13. I get a 3 here. 3 over here is going to give me a 17. So what I can do is I can take a 25 into 13 out. So 25 into 13 divided by 25, right? And what I get inside is going to be 2 into 17, which is 34, plus 25 into 13 is out, so just a 1. 25 is cancelled. Supposed to be a 13 into 35, 350 plus a 105 comes to a 455. Option 4 over here becomes the answer. Right now, it just looks neat and sweet, but during the exam, this is a question where it took me quite a bit of time.